Okay, here's a quick review of the results some of you may have missed in your absence. We'll kind of keep them separate here. We've got sort of the green side and the brown side. So we start over here on the green side with some function, some f of x. And what we're going to do is we're going to take the area under this curve and create an area function. That is to say, what function is created as area accumulates in this manner. And as you can see here, kind of like filling up the gas tank, except sideways. We, from 0 to 1, have accumulated some area. Go ahead and put a scale. 1, 2, 3, 1, 2. An area of 1. So when we make an area function, how do you like that for sound effects? Sounds just like real dogs. The area starts at 0. By the time we get to 1, we've accumulated 1. We accumulate no area here, and by the time we're done, our area has reached 2. So we get an area function. Then what we're going to do is take the slope of the area function. Feel free to pause the video and do that. That is its derivative. Slope is 1. From here to here, the slope is 1. Not really defined at those corners. Here the slope is 0, and here the slope is 1. And lo and behold, what we see, if we take the slope of the area, we get the original function back. Pretty cool. Slope, as we might choose to say, undoes area. Let's see if it works the other way around. Let's, instead of taking the area first, take the slope. Bloop, bloop, 1, 2, 3, 4. Notice I picked a nice convenient function to work with. This is linear. The slope is, here's 1, 2, 3, 1, 2, 3, 4. The slope is a constant 1/2. So here's our slope function. Easy enough. Now let's take the area of the slope function. Let's see what we get. 1, 2, 3, 4, 1, 2. As we accumulate area over this accumulating area up to 1/2, up to 1, 1.5, 2. So it goes from 0 to 2. Lo and behold, we have the same function we started with. Almost, but not quite. Notice that? It's the same slope, but it's starting in a different place. So it's not quite that simple, but it's pretty close. The area of the slope is the original function, and the slope of the area is the original function, more or less. Meaning slope and area would be inverses of one another. We can write that in calculus, roughly, our first draft, writing that in calculus. The slope of the area, that is the derivative or slope of the, we're going on some interval from say 0 to x. We've got to clean that up a little bit. Whoops. The slope of the area of the function is the function itself. Looks pretty cool when you write it out that way, huh? And similarly, the area, 0 to x, of the slope, the derivative, is the function we started with. Just kind of two sides of the same coin. In your book, you'll notice a fundamental theorem of calculus, part 1 and part 2. So these are inverses of one another. They say the same thing, but slightly backwards. We'll have to clean that up, but that is essentially the idea behind the fundamental theorem of calculus.